Okay, we're starting stream 12 up. Been having really great luck with the transcoder. I wonder if Twitch now has so many transcoders you'll basically always get him. Because I'm not even an affiliate, I'm getting the transcoder. So today I can stream until 10-ish. A good 2.5 hours at least. All right. So if you haven't seen this series yet, and also in order to give myself some practice in giving an overview of what I'm doing, let me talk about what this is. So this is a domain-specific language for processing data, basically figuring out what the components of a file or a packet are. In this case, I kind of picked as an example GIF, but if I wanted to, I could write a syntax for anything. And the goal is to write a tool that can use this specification to pick apart a file into its pieces and do interesting things in it, like display them, fix them, that kind of thing. Hey there, Nightshade dude. Are you watching me and Prime at the same time? Because you were just in there. So, yes. So, how can you do that? How can you watch two streams? I don't know how people do that. So, there are three parts of the tool. So, the first two parts are the compiler. So, if you know about compilers, you know that you need to first take your program, and the lines and columns of the program need to be converted into a stream of tokens. So that's an identifier, that's a symbol, and then another identifier, etc. There's a reserved word, there's a literal number, here's another kind of literal number. So these get turned into a token stream, and that's what the lexer does. So that's what it looks like. So that's the first part of the tool. The second part is the syntax, the grammar, the parsing of the program into an abstract syntax tree. And we do that with a collection of grammatical rules that give meaning to the tokens when they're in a certain order. And for example, an expression could be a literal integer, or it could be an operation like left shift. So we're using grammar rules specified in what's known as Bacchus-Nor form, where you have some kind of construct like a expression, and what are the rules that will allow you to construct that expression from smaller pieces. So for example, an expression could be a smaller expression, left shift, and then another smaller expression. And when we match a sequence of tokens or constructs and recognize that it fits in the syntax as something larger, we do what's called a reduce. So we take these tokens out and replace it with a smaller one, and attach to that the data that we decide to fit into it. And that forms a node in a larger tree-like data structure called the abstract syntax tree. So you can imagine if we look back at that format, we would have here a data tree where GIF is at the root, and it has a child header, a child logical screen, a child for data and trailer, and header itself has its own children, signature and version, etc. And that's step 2 of the tool. So steps 1 and 2 get the format specification into memory as an abstract data tree. Step 3 is we do an in-order traversal of that data structure alongside an actual file like this one, only the computer's going to see it like this. The data structure memory that we're traversing in order, matching it up with the bytes of the input, let us recognize that, hey, the first 3 bytes, that's the header's signature. Next 3 bytes is the version. And then the next 2 bytes after that forms the width of the image, 300 pixels. and etc. 2 is your max, and some people's voices you can't do it. So that means Prime's voice and mine must be compatible, and I'm honored. So I already have this tool. You can kind of figure that out by the fact that I can actually run it and it actually generates output. It is something that I wrote about 5 years ago, but I didn't get it completely done. It has a command line interface, and I wanted to have nice user interfaces, like graphical interfaces for this, kind of resembling what you have with data dissectors in Wireshark. So the same idea, right? You're looking at a packet, and you can see the raw bytes of the packet, but if you want to, you can also click on a range of bytes, and it interprets what it means. So that's what my tool is doing, a similar thing for. Somewhere inside of Wireshark in the dissector's source code, there's a process that's taking in bytes and matching them up with the syntax of the protocol and saying, okay, well, those first 2 bytes identify it's an Ethernet packet, and then the next 2 bytes say it's an IP, and then the its next 2 bytes says that the hardware size is 6 or whatever, So for mine, though, it's very generic, not just for any one format. It's for any format that you can describe in the domain-specific language I invented for it, which I like to point out is unique in that, well, it's different from general-purpose languages in that you write these constructs that have a dual nature. So they look like structures, and they also look like functions. So a GIF does start with a header and end in a trailer. So you can think of these as members or fields of the structure. But we also have loops, and we also have conditional logic. And that flow of a function maps to the structure if you think of an in-order traversal. So if you're looking at a GIF file, the first bytes you're going to encounter are the header. And in the header, the first bytes you're going to encounter are the signature, etc. So that's how the structural and the functional elements come together, is through the in-order traversal with an actual file that matches this format. Pretty cool, huh? So written in C, I used Flex and Bison to generate the first 2 pieces, the lexer and the parser, which together form the compiler of that language. This is what the Bison input file looks like. So, for example, a statement, the body of a statement could be like specifying a part. So that's like what matches header. So that's a very simple part where it's just an identifier of a subformat. And then all these optional things, we don't have any of them. You can have an if statement, right? If left parentheses. So you can kind of see how this is specifying all the parts that together construct an if statement. And then a for loop and a while loop, right? So again, so that syntax you can kind of imagine matches this, because we have the while keyword, we have the parentheses, we have the loop condition, we have the brace, and then the statements in the right brace. And kind of like the Rust version of this, whenever we match a rule, we reduce it to the type, which is a statement body, and then we run some code to generate the data, the node in the abstract syntax tree that will go with that while loop, that statement. So again, Flex and Bison is what I used back 5 years ago to do this in C. In Rust, I am using 2 different crates. So for the lexer, I'm using Logos. This is project open source. Can't open source it right now. Would like to, but the job I have doesn't let me publish anything open source. So Logos for the lexer. Everything is a attribute macro, which is kind of cool. So you just literally attach attributes that say how to turn input text into the tokens. Like if you encounter I followed by F, it's an if statement, right? If you encounter a string that matches this regular expression, it's literal binary. Yeah, so because I can't publish anything open source without quitting my current job, I settled for showing you 25 lines at a time and leave it up to you to be inspired to write your own. I think the biggest thing in sharing software is describing the foundations that we build upon and then the techniques. So, for example, I didn't write the Lexer from scratch. I built this on a foundation of the logos crate. So you can literally type the logos command and my bot will tell you where to go to learn more about how to make a Lexer like I did. It only took me 7 hours to do this. So it would take you 4, I'm sure, right? Because I'm slow. So that's the Lexer with logos. The grammar we're using Lollipop, which is a hilarious name in my opinion. LALR stands for look ahead, left, right. So that's just a general parser generator technique that you can read about on Wikipedia. And pop because it makes it sound like a lollipop. If I'm slow, you're stopped. Everyone's different, Nightshade dude, and it depends on what you're doing. I'm probably a lot slower than you are at whatever it is that you specialized in or happen to be doing this year, right? You're probably much faster. So the cool thing about Lollipop is that it's Rust-like, but it's not. It's also using a structure similar to what we had with Bison. So we have like, let me show you something smaller. So this optional identifier list, right, is 2 alternatives. Either it could be empty or it can have an identifier list within parentheses. So we have the same thing here. In Lollipop, it's just more compact because the code that we would do is generally a lot more concisely stated in Rust. And also, I omitted the comments and stuff. And anyway, it's very similar though. So an optional ID list is either empty or it's a left parentheses, an ID list, and right parentheses. Same thing as we had here. And if we match the rule, we need to assign this double dollar equal is we're assigning what value goes to that node in the abstract syntax tree when we match this rule, right? And so that's going to be the right hand side of this arrow. So it's none for 0 tokens. And if we have 3 things that we reduce, it's sum, and we pick out the ID list from the middle. Same thing we did here, right? That is picked out there. So the way we integrate the parser with the Lexer is that certain things have are represented as strings. So these are like individual tokens or elemental constructs, and we have to map them at the bottom with an extern block. So we say like a left parenthesis is this variant of the token type from the Lexer. We also assign types to the generated parser that are shared with the Lexer. So the location in the source code and any errors use the same type. Hey there, Sarian. Gotten used to hearing me on 2x speed. Now it's weird hearing me at normal speed. So you, just like Adam, like to listen to people at 2x speed. I have to admire you and Adam, because that means that you only take half as much time to listen to someone. But yeah, you have that issue that if you're in real time, you can't really do that. Here we go, Sarian. You can listen to me in minute-long segments in 30 seconds and then do something else for 30 seconds. You can just pretend that every 30 seconds I took a 30-second break, or every minute I took another minute break. And multitask, right? I'll leave it up to you to write the browser extension that will play Twitch at double speed after buffering it. You're going over my VODs? Well, yeah, that's cheating. So I don't know if you saw, Sarian, I did stream last night, and I encountered the problem with Lollipop that it does not let me specify precedence between operators like we used to be able to do in Bison. So we can't do this in Lollipop. And their manual talks about the alternative is to use these, what does he call it? He has a name for it. It doesn't have built-in precedence operators because he considers them creepy. Fine. So he calls them tiers. So you break the grammar up into different levels or tiers. So you have the non-terminal expr, and then you have the intermediate factor and term, and then you have the terminal num. So I'm like, okay, we'll just do it his way. So in Lollipop, I've broken up expression into as many tiers as I'm going to have based off of which of these operators are used in expressions. So it's most of them, but not some of them. Like commas, not, and dot, left paren, right paren are not also, because that is used in other grammar elements. I probably didn't even need to have them in the precedence list, but most of the rest of them are. Actually, this one's not. So I think these, starting from here, these are. And so I already have the in, and I have done left shift, right shift, and I've done not and flip. So last night I stopped it there, and so we have left to do. We have to do negative, decrement, increment. We have to do or and we have to do all the ones in the middle. So I think I'm going to do all these ones in the middle, and then finish up with the ones lower precedence than in, and then I'll add in these ones that are missing. It's got episode 9 and 11. I haven't uploaded all these to YouTube, so you have to look at the Twitch VOD for now. The Wrapped, how are you doing? Doing operator precedence is fun? Yeah, so what I kind of figured out is that something like a non-associative operator, which means that you can't chain it, so you can't have A in B in C. It's a syntax error. The way we do that in Lollipop is we'd have the higher order expression, so to speak. So expression at level 9. You can have two lower level expressions, like level. Actually, this needs to be updated to a 1. So why don't we just do it now? You can use lower level expressions and have them within. So this prevents you, this is non-ambiguous now, it prevents you from doing A in B in C, because A in B cannot be expressed as an level 1 expression. It just can't be done. Neither can the right-hand side be an in expression, because it's also a lower level. But if you can chain them, like A left shift B left shift C, you do it by picking associativity left or right. If it's left associative, you for level 1, you do the same level on the left and the one lower on the right. So that allows the left one to be also a left shift expression, like A left shift B, and then left shift C. A right associative would be backwards. You'd have 0 on the left and right 1 on the right. So I figured that out last night. Doing good. You might get a job offer. Oh, nice. Good job. Friday the 13th seems not like a bad day after all. That's the thing about what do we call those superstitions? That they are what you make of them, I guess. You could think of Friday the 13th as a lucky day now, not an unlucky one. Okay, so I should probably have a test to make sure that this test should. I should make a test that fails unless this is a 1. So I guess one way to do that would be, I should be able to form a compound expression like A left shift B is in C, right? And then this would fail because this wouldn't allow me to do a left shift there. So why don't I just add a test for that? Since I have these lovely test cases already. I think it mostly matches this one, right? Yeah. So we're gonna make a test that kind of mingles the in operator with left shift. So this is A left shift B, then in C. And I could have made an A in B left shift C if I wanted. So yeah, we're gonna have to have another token. So like, I'm just using integers because they're easy. So let's say 23 and then left shift 10 in 42. So because this is higher precedence, it's going to look like this. You do the left shift first, and then you see if it's in something else. So that means the in is outermost, and then the first one is going to be this compound expression operation. So it's going to be operation left shift. And we're going to have two expressions inside instead of one. So I need to like make that the 23 with the comma and then an extra set of parentheses there and there, right? So this I expect to fail because of the grammar rule being wrong. Let's watch it fail. So it fails. We get error, unrecognized token in. So it gets to the in and says that shouldn't be there. That doesn't match any grammar rule, right? But if I fix this so that we allow level 1 expressions, actually that's the only one I need to allow, right? This one would need a separate test. That's the minimum to make the test work, I think. Now this should pass, and it does. So if I really wanted to be verbose and pedantic, I would make another one to handle expression 1 on the right, but I'm not going to bother with that. I'm just going to fix it. Does a lot of pop support left recursions? For left associative operators, usually have a rule. Yeah, I mean that's what this is. That's left recursive, right? By left recursive, do you mean left associative? So this allows the one on the left to be a left shift operation. Like you can have this one could be A left shift B and then left shift C. Or do you mean it the other way? Like A left shift B left shift C. That would be right associative. And there I don't support that unless you put the right in parentheses. So this is the reset rule where you get down to the highest precedence where you allow you allow it to go back to the top of the expression hierarchy as long as it's in parentheses. So yeah, the way you wrote it was 1 equals 2 and then in parentheses. Yeah, so that's with this, I think. If I understand you right. But left recursion, you mean that in top-down parsing, the parser for 1 recursively calls the parser for 1, resulting in an infinite loop. Yeah, this one is going to 1. That's an infinite loop. It's supported. It's not truly infinite because the parser will do shift and reduce operations until it consumes all of the tokens in the stream. So the token stream would have to be infinite itself, right? If you can imagine, like if you, in here, you said, or do I have a value? Like if I had 1 left shift, 1 left shift, 1, and I just did that forever, right? Like this. That's still, no matter how long I hold this down, it's still valid because it's going to recursively parse that infinitely as far as we go, but we can never be truly infinite in our input. So eventually it's going to consume all of it and reduce it down to a single expression. So as long as the grammar is not ambiguous, so we disambiguate it by having a 0 here. If there was a 1 there, now it's ambiguous, right? It's non-associative, but it's in the same level. So now if I try to build that, it's going to complain that it's an ambiguous grammar. And actually the error messages are pretty nice. See? It says if we have something left shift something, right shift something, it could be that and then right shift that, or it could be that left shift all of that. There we go. It's ambiguous. It doesn't support ambiguous grammar. See the manual. Oh, look at that bug. Did you see that? Can't make it happen again. There's a VS Code bug where it doesn't highlight. The highlighting goes all wonky. So yeah, as long as it's non-ambiguous, I was able to put the same level on both sides for an in as long as it's in a higher order one. All right, that's the only way to do those non-associative operations. All right, I think it's time to add another operation. So should we do divide, multiply, and modulo? We can do them together, I guess, because that'll be expression level 2. So let's do it. So let's make, maybe just make a copy. I copy 9 because it starts with a nice in. Copy paste. And that's expression 2. Okay, so tests needs to say that we have an expression level 2. So, by the way, you might wonder why I picked 9 there. That's because I was looking ahead, so to speak, in my operator precedence order, and I simply counted. If that's 1, then there's 2, 3, 4, 5, 6, 7, 8, 9 is where the in is. And we'll have a 10 and 11 also. Okay, so for 2, expression 9 becomes expression 2, which doesn't exist yet. So let's go and write it here. Expression level 2. I guess I could have copied from 1 now that I think about it. 2 is it's left associative, right? Yeah, they're all left associative. So it's going to be a 2 on the left and a 1 on the right. And this is going to be whatever the symbol is for, actually, I guess it's exactly this, div mod mul. Div is div. Mod is mod. 2, 1, and then we have the pass-through rule. And then we have mul. Mul. Okay, so these tokens, we have to add them to our mapping with the lexer. So that's here. Struggle with the keyboard to get better. Mod and mul. There we go. Okay, operation doesn't have div mod or mul either, so we need to add that. Avoid repetitive motion injury, my friends. It's not fun. Mod, and we have mul. And we have div. Cool. So I hope I answered your question, Marty, that yes, we have left recursion. That's what we're actually using here. Okay, define that. We defined these. Oh, this needs to be updated to a 2. Okay, so then the tests, right? This is just copied from 9, so we need to update it. So this will be div. So we'll have 10 divided by 42 should just be a div there. And then we have not A, then div B. Actually, I don't know if we need to be this exhaustive at this level. We could have like a ton of tests for every level, and it would maybe not be really that necessary. Maybe I might just choose to follow the philosophy of adding a test case when I have a bug. So the philosophy is you don't need to over specify your testing. You just you write some tests in like a pretty good baseline, and then as you find bugs, whenever you fix a bug, you require yourself to write a test to check for it. So I can say, well, not A, then div B. We just assume it works until in using the tool later it doesn't, and then at that point add the test. Same thing for this stuff, because otherwise our test files get like humongous, right? Same thing for the invalid token. Like this, it's just going to be too crazy to test all of that, right? That should be a 9. No, a 2. Okay, so then, because then I can just have one div, one reasonable, right? One div, one mod, and one mul. So I can just easily type that and then type that and I'm done, right? So then we can just run all these tests, make sure they work. Okay, what did I forget? There's an unexpected found keyword because mod, it doesn't know what mod means. Oh, mod is a keyword. So when we run into this, I ran into this last night. This test case crate names tests after what we put here for the name. We can't put the name of a keyword. We have to put an underscore. Then you can see it allowed the name. Okay, we're passing. And then I might as well like run all of our tests here. 48 tests pass. Awesome. So that means we have this level. So we'll just keep going. So next level will be minus and plus. So that's level 3. Yeah, because I'm just thinking like, do we want to make sure there's nothing below 0? Because otherwise I have to renumber a lot of things and that would be tedious. This is not used in expressions. That's used in references, right? These are used in expressions. So that's 0, 1, 2. Cool. I think we're good. So minus and plus. Let's add that. So expression 2, we're going to copy to 3. Okay, so then tests needs to have a mod expert 3. Can I have it not show that ever again? That would be sweet. Okay, 3. All of the expression 2s become 3s. Looks good to me. And then minus and plus. Minus plus. So that's minus and then plus. And then we don't need an underscore there, right? And then we'll just take this out. Okay, couple things. We need to have the grammar. We're going to have minus and plus in here. We have minus. Oh, we have minus and plus already. Nice. Because we use them in level 0's unary expressions right there. And hopefully we don't have ambiguous grammar. I don't think it's going to be ambiguous because this will disambiguate from A minus B because there's no A in front, right? So if we start with minus, we know it's the unary expression negative, right? And plus is somewhere else. I forget where. Oh, it was optional look ahead. So yeah, I think all we need to do is copy expression 2 to 3. Put a 3 there. Put a 2 there. Make this one minus and make this one plus. Get rid of this extra one and make that one a 2. Run our tests. Nope, I missed something. What did I miss? Oh, we don't have operation minus and plus. Yeah. So that's minus. And plus. Plus. Look at that, first try. 50 tests we're up to now. So now we're on a roll, right? We're just going to keep doing it. So that's now we have all the less than, greater than, less than, equal to, greater than, equal to is the next level. So again, we copy, paste. This is now expression level 4. Can't help feel, but that operation enum could be a bit less redundant. Yeah, the original parser I had. Oh, where do I show that? Maybe down in the rules. I had binary operation and then had a sub-enum. And I thought about doing that last night, and I'm like, I'm gonna have, like, it's just a question of one larger enum versus two enums. This I think I went against this one because this makes this one a little bit complicated. It's gonna be a tuple of left operand, right operand, and operator. Versus here, that operand, the operator is actually a variant, and I just have these repeated. We can change that. I can make, so it would be, we would reduce a lot of this to just binary and unary, and binary and unary would have either one or two expressions, and then I had to have a second level enum to say, well, what's the operator? A data disintegrator is like a paper crusher. Hey there, Perkin J. Data disintegrator is something that chews up data into its bits. So using this specification for GIF on this file, which looks like this to the computer, it completely disintegrates this file into its pieces. So it says the first 3 bytes is a signature, the next 3 bytes is the version number, the next 2 bytes after that is the logical width of the image. I'm not very good with names, so I just came up with, like, what's a good name for something that takes data and like cuts it up into its elements, right? Disintegrate, right, is unintegrating the file into its components. I think Wireshark calls them dissectors. So these are data dissectors, right? Take this data, dissect it into its pieces. So I couldn't use that word because someone else is taken. It's taken. Okay, expression 4. So we're describing the syntax in Rust right now, and we're working on the expression grammar. So there are lots of different expressions with different operator precedents, and we're doing all that right now. So we had just done divide, multiply, and modulo, and minus and plus. This is how in the Lollipop grammar we would do the order of operations between adding and subtracting and multiplying and dividing. So you make the lower precedence operator higher up, so expression level 3, and then you do a left associativity by having the higher order and then the operator and then the lower or the lower tier or the higher precedence on the right hand side. That's left associative, and in that lower tier you have the higher precedence. So if you had like A plus B times C, it would do the B times C first by matching this rule first as an X per 2, and then you'd have it go here plus your A on the left. Hopefully that makes sense. Yes, Ariane. So I'm actually kind of thinking now that this does look redundant, and we'd have to have another level, but I can do that separately, I hope. Or should I do that now to avoid the pain of having to go through all of these later? I don't know. One advantage of having it one level is that I only need a one level of match. If I have a second level, I'd have to first see, oh, it's a binary operation. And then, okay, what binary operation? Have a match on that one. This one, I can have just one huge match. I don't know what's better. Operation has an associated trait to implement. You only debug and partial equal. Really, it's just describing what to do with two things. So if it's operation div, that means these two things, divide them. And it's done when we're actually parsing the actual data. So when it actually is pulling apart things, and if we reach, what's an example where we actually add? Like if we're parsing a color resolution, we read 3 bits as an unsigned integer, and then we have to add 1 to emit the value for color resolution. So this is the point where in the abstract syntax tree, we would run into an operation plus, and then the 2 expressions on the left would be a reference and a literal. And the reference would go find that this reference is what we already parsed a moment ago. And it would say, okay, whatever we parsed those 3 bits to be, add 1 to it. That's kind of how it works. True, but depending on how your evaluator works, you'd only the outer binary outmatch evaluate the left and right once, and then figure out what to this, that, and the other thing. I completely misused that terminology, didn't I? I think it's just a matter of how I want to organize it, right? I don't think the computer's really going to care much. End up evaluating the... Yeah, but each arm is a separate bit of code. So there'd be more code, maybe fewer steps. Oh, I mangled the reply too. I'm not like solidly believing this is the right way to do it. I'd be open. The other way seems fine too, and I'm sort of on the fence. This is the lazy approach where I was too lazy to make another enum called operator. But you know what? You know what might convince me is to remind myself that in the C implementation, I did have that separation of 2 enums. So if I want to remain true to the original implementation, I would do the same thing. Which arithmetic operators are you implementing? Is it floating point? It could be floating point or integer. I have the notion of automatic conversion or coercion of types so that they're compatible. So, for example, we had one of those in GIF right here. So the aspect ratio is encoded as 8 bits, and if it's not 0, you have to add 15 and then divide by the floating point 64. So the way this would work is there'd be a divide operation, and the left operand would be itself another expression, which is an add, and then there would be a reference, add, literal. And since the reference goes to an unsigned integer, this would be integer plus integer. And so you get an integer, and then the divide operation would say, well, I have a float on the right and an integer on the left. I need to promote the integer to a float, then do the divide. So it's not as strict as Rust, which would require that I like specifically say that this needs to be that, right? Or that, as that. I'm not that strict. There's like, it's more like C where there's like automatic conversion rules. And which operations, there's a nice summary here at the top. If I show you my list of operators, so these are the operators. So we have logical or and. We have in, as in like something is in a set. We have inclusive and exclusive or. We have the bitwise and or mask. Equal to, not equal to, less than, greater than, less than or equal to, greater than or equal to. We have adding and subtracting. We have dividing, multiplying, and the remainder or modulo. We have left shift, right shift. We have bitwise. No, that's logical inversion or not, and flip is just flip every bit. So bitwise not. And then these are technically not operations, they're statements. They're like make something its negative, decrement and increment something. So those are more like statements and not operators. So I guess these are operations that we can do in expression context. Assign, accumulate, negative, decrement, and increment are more like statements. It's like if you have plus plus x. It's like this would be like x plus equals 5. Technically, that's not an expression, it's a statement. You could think of it as an expression, especially if that in some languages might return something, but it's primarily the side effect of taking what x was, adding 5 to it, and storing it back in x. I think of that as a statement. That now it's a statement that that has an expression on the right-hand side, but not an expression on the left-hand side. It's a reference. Some languages are more flexible, and they would say, well, the left-hand side can be an expression, but it has to evaluate to be an L value. In other words, a reference to like a named something we can change, like a variable, right? But my language is a lot less flexible. They're considered not even expressions. They're statements, and then they leverage expressions, but they're not themselves expressions. So they're not considered operations because only an expression uses an operation. Where do I say that? Yeah, only an expression has an operation. Variant? Yeah, the operation is only a variant of an expression, not anything else right now. So yeah, we're basically, this is going to be a filled-in Rust form of all of this, and just talking to Sarian about how I should probably split this into 2 levels. So actually, maybe let me do expression 4 first, right? Expression 4 was going to be the next one up from minus and plus, which I've already forgotten what it is. Less than greater than, less than, equal to, greater than or equal to. That's what it is. So does tests have, yeah, expression 4. Expression 4 has less than, greater than. Oh, why am I typing it there? I should type it here with multi-cursor. Less than. And then here it's greater than. Because we're following this, right? And then it's less than or equal to, greater than or equal to. So this one, less than or equal to, and this one, greater than or equal to. Okay, exper 3 needs to turn into exper 4. And then we need to put it in the grammar. So kind of like what we were doing before, we'll just steal 3, turn the 3s into 4s, turn the 2s into 3s, and make minus into less than, plus into greater than, and then 2 more times. We have less than or equal to, and we have greater than or equal to. Did I do that in the right order? Less than, greater than, less than or equal to, greater than or equal to. Yeah, there we go. And they're all left associative, which means the level we're at stays on the left hand, and then the right hand has to be one level lower. Okay, save that, and then operation. This is the last time we'll be duplicating expressions. So we have less than or equal to, and we have less than, and then I need the version of that for greater than or equal to and greater than. Okay, let's see if did it first try. Nope, because I forgot the mapping between the symbol and the token. That's down here. Less than. Is doing a lot of leak code a good way to learn how to program? No, leak code is a terrible way to learn how to program. Leak code is what you do when you're bored and want to be challenged about esoteric things like puzzles. If you like doing puzzles, I guess. I wouldn't say it's a good way to learn how to program. It's more of a way to like challenge yourself once you've learned it to a certain level. If you want to learn, you want to pick something easy so that you're focusing your brain on the language, not the puzzle. That makes sense? If you don't know the language and you need to solve a puzzle, you're doing 2 things at once, which is harder than doing 1 thing. The 2 things are you're learning the language and you're solving the puzzle. And now some people are gluttons for punishment and find that attractive. Hey, I like doing 1 challenge, and I like doing 2 challenges even more. Now, sometimes I'm like that, and I'm like, hey, I want to solve this puzzle, and I also want to get better in Rust. Let me solve the puzzle in Rust. But yeah, sometimes Sometimes that's not the best way. If you really want to learn something, focus on the learning. Pick something easy. Go through a tutorial where you don't have to solve it. They've solved it for you and they kind of walk you through the solution. And what would I recommend then? Not LeetCode, because LeetCode is full of puzzles. I would say like any tutorial that you can find on any language that you find interesting. So you like JavaScript, find a JavaScript tutorial. Maybe there's tons of that stuff, right? There are tutorials on how to build a website with React. Now you'll learn React and you don't have to worry about how you design a website because they're just going to walk you through it. Now, once you've learned to a certain level, then LeetCode can be fun because it's leveraging your learning and solving a puzzle with it, which keeps you engaged. Because at a certain point, you'll start to get bored with the learning part and you'll be like, I want to do something fun. Okay, well, let's solve a puzzle with what we know so far. Okay, as usual, I've over-explained that. Cool. Passing all the tests, I think now we'll take the opportunity to, like Zarian pointed out, and then I have in my own code here, split operations into two things. The type of operation and then the actual operator. Now don't take it just from me, Flev from Nowhere. Get a second opinion. So is it okay to have operator in the same place? Really, it's a second level enumeration, right? It'll be like there's operation and then there's like binary operation. Okay, so let's just take all of these and paste them here and delete the ones that aren't binary operations. Right? Okay, and then we're going to take all of these. Add cursors to line ends. And then go to the beginning, go one word over, go all the way to the end of the line, and delete. And let's call that binary operator, because binary operation is just going to be a kind of operation. Here, I think I'm going to, because I'm going to have three things, not just two, I'm going to move from having a tuple to a structural thing. So that's left-hand side is an expression, right? And then we have the operator, binary operator. And then we have the right-hand side is the expression. Okay, and then that means we get to delete all of these. And I guess while we're at it, we'll do the unary operations. So there we only have left-hand side, we don't have a right-hand side, and it's unary operator. And that we get from here, which I'll just cheat and I'll just do this, and then I'll copy this, paste it, and change binary to unary, and I'm done, right? No, I'm not done. I gotta go to line ends, go to the beginning, go one word over, go to the end, delete. Cool. And I'll even put it in the same order in which we use them there. Nice. Okay, so then that's going to mess a whole bunch of things up, right? Now we can't even build. Interesting. I thought that our grammar would break. Our grammar should break, right? Because that shouldn't. So let's see. Our grammar should have broken. Our grammar didn't break, probably because the code generator doesn't care if the type is valid or not. So it's really in our tests that we see it break. Oh, no, it's also in the generated code, it breaks. So let's do the grammar first. So here where we have expression operation, right? We'll just globally do all of them to binary operation. Go one word over, change that to a bracket, do op, no, bracket, and then one word, oh, 1, 2, 3 words over. Actually, here we can just get rid of the box, right? And do binary operator, and then comma, delete, delete, word, 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 brace. Back here, put an op. Okay, and then all of these RS, we need to delete 2, 1, 2, go over. Actually, we'll just turn that into a brace and then delete that one. There we go. So, did I damage anything too severely? Okay, we damaged all of the unary operators, so let's just fix them now. Unary, and this is op unary operator. Delete that part of it. And then a couple words over, we have right hand side is E. Actually, let's get rid of that and just simply call this one instead of E. We'll call that one the right hand side. Looks good to me. I did call it RHS, didn't I? I call it left hand side. It's really right hand side. Fixed it. Okay. We have some damage here. Fix the damage. This looks good to me. So then let's fix the make sure that builds. Oh, maybe I didn't fix it. Calendar invitation. It's giving me a calendar invitation. Oh, canceled. Okay, never mind. Someone's canceling a meeting. Oh, yeah, we have a problem in the grammar. Yep. Here. That space needs to be a colon. Use of undeclared type binary operator. Oh, we need to declare it. Okay. Or unary operator. Oh. All of those are wrong. Yeah, okay. Shoot. All the places where that happens, we have to put oper. Oh, wait. No, that should be defined. Did I mess that up? Expression Oh, shoot. No, we have to have, because an expression might not be an operation. Yeah. Well, they don't match what you wrote. Maybe that's a better layout. Oh, you mean like instead of having just operation, I should have binary operation, unary operation, rather than having it split it out like that? Actually, that is what I did in my grammar, isn't it? Where is it? I would just need to box both of them, right? Which I forgot to do. There we go. Yeah, I didn't have that second level enum at all, right? Or that there are two of them, but I didn't group the unary and the binary together as an operation. No, but I need to do that because I wanted to put left hand and right hand side in only one place, but they could go here, couldn't they? Yeah, so combine that with that, it would be this. Which means this is probably going to be called operators. So that would really go there. And this needs to be boxed. That means I'd want to box both. Well, I need to box the expressions, right? So now we have two boxes instead of one box. That doesn't really matter, right? So then this goes away. And we don't need to use expressions, so it's actually a little bit cleaner. Okay, yeah, I want to rename that. Operators. So it's not like your enum gets bigger. No, it's just kind of moving things around. Same size as string. Is it? File, save all. So that's binary. Actually, this will do the import for me, right? That's wrong. Okay. Just sorting. I think it's cleaner anyway. Yeah, I think that was a good move. Okay, but yeah, but this does need to be cleaned up, right? Actually, no. That's actually how I wrote it. Only problem is I need to box these sub-expressions. So all of these need to be boxed. Box. How come I didn't pick them all? Pick all the LHS, RHS. Box new, word over, box new. That. And the unary operator also. These ones. Let's clean this up. It's a little bit easier to read. Actually, I guess they didn't need to be on the same line. I mean, they didn't need to be on separate lines. Could do that. It's easier to read that way, not that. In fact, I could probably clean this up too, right? So all of these, I can do cut, go to the left, paste. Left-hand side in, right-hand side. Okay, I like this. So clear, run again. Make sure that okay, so there are grammar problems still. Missing RHS, okay. Yeah, all of these, RHS colon. Missing fields. Wait, how? Oh, I forgot to put LHS, RHS in front of them all. Well, shoot. LHS. Why did my eyes not see that? I don't know. There. I love multi-cursor. Removes a lot of the tedium. Cannot find operation in crate root. Did I not save that? Oh, because it's not operation, it's operators. And that doesn't exist. Oh, wow. It just built? Wait. Oh, but that's because it doesn't build the tests. If we try to run the tests, it's going to have more errors, right? Yeah. I'm like, I didn't fix the test yet. How could that have built? Turns out you don't have to have working compilable tests to actually build a crate. Okay, so then ORs. Binary. Actually, let's just delete that for now. Expression operation is expression unary operation. And then over here, that's RHS colon. Actually, let's do it the other way. So we go all the way to operation and we type in op colon, and then this is operator, this is unary operator, and then comma, RHS colon box new. And then we need to replace that with a curly brace, and over on the left, a left curly brace. And we have a lot of extra, oh, no. All of those need to extra. Go to the next line and just delete the line, I think. What am I missing here? How come I'm not seeing the... What am I missing? Oh, the OK. Needs to have another parentheses. There we go. And then, yeah, unary operator needs to... How does it only allow me to qualify as? I want to import it. Great operators. There we go. Okay, that's 0. And now for 1. So binary operator, expression operation, all of those. It's binary operation, and then it's op colon, seek to that, delete binary operator, comma, LHS is a box new, delete once, good. A couple words over. Okay, we're already going to be screwing things up, aren't we? So multi-cursor, not the best idea. Okay, we'll just do this one. Okay, take all of that and put it there. And then that's an RHS box, new that. And that turns into that. That's one. Yeah. That part goes there. That is the left-hand side, right? Not all of that. Hold on. A, left shift B. Yeah, so the left-hand side is A, left shift B. So that's this. And then this part is the right-hand side, which is just the C part. Okay. All right, so then this is expression binary operation. Actually, that wasn't so bad. It just like the nested ones are a little funky. And then like I need one of these to go here. And that turns into that. That goes away. Okay, one more time. 10 left shift, so left-hand side. That's just this one. That goes there. And then we need a right-hand side box. Get rid of that. So this, yeah, this goes there without the spaces. And right-hand side box. That turns into that. That. How come it... Oh, right. It doesn't auto format that. Okay, so that's one. Now two. Glad I didn't go too far all the way to 9. Yeah, it's a little bit of tedium. This one's more straightforward because all these three are the same, right? Binary operation. And then we have like the op, which we can take that, oh, well, take all of this away and box that and that. And that's right-hand side. And that's a left-hand side. And that's a comma. That and that. Good afternoon, ICS by X. It's part of why you're trying out Insta, so expected output generates for you. You need to check the new snapshots. I still don't quite understand what Insta's gaining for you other than memoizing your expecteds. You're saying like maybe you don't have to write all this crap because you just run it once and it gets memoized and then, yeah, it kind of generates this for you. Okay, did I do this right? Actually, I should be using multi-cursor for this, right? Because they're all the same. Ah, we had too many of these lines, that's why. Okay, op operation is operator and it's binary operator. Cool. That was 2. Moving on to 3. You have to write all that. You also went the lazy route and just call your Alexer to get the tokens. Yes, we're working on a DSL. And I already closed it, so let's open it again. Here's the oh no, I didn't close it. Here's the DSL. So it describes how to parse binary data. Very similar to how the dissectors work in Wireshark. Given some bytes, how you figure out what the bytes mean. So I picked the GIF file as an example, so that when we run this is the C version of the tool. It's able to pick apart, the header is that when it's looking at these bytes, right? That matches up with this format because parse the first 24 bits as a string. There we go. Make sure it's GIF. Next 24 bit string has to be one of these, and so on. So that's the DSL. Is that. So working on the grammar rules for that DSL right now. And I changed the way I'm in the abstract syntax tree, this output from this grammar, how we represent expressions. So rather than having an operation expression, there's now 2 different kinds, and we have a second level enum. Instead of having it all the operators, we have them split now between the binary and the unary ones, which I think more and more I like this way. The cost is that for binary operations, we have to box both sides, and then we also have a little bit of tiny bit of redundancy in that both of them have an op and a right-hand side, and this one has an additional left-hand side. Commented on the redundancy the previous way it was done. That's fine. A little bit of redundancy isn't too bad. It just drives us to try to find ways to reduce it, right? Okay, so this was binary operator. Okay, this shouldn't be too bad. We just did this, right? So that becomes binary operation. That goes to op. That comes to binary operator, comma, RH or LHS box new. This expression RHS box new that. This level goes away. This comes to that. Easy. We're on a roll. Let's do 4. Binary operator. Binary operation. Op is binary operator. LHS box new that. RHS box new that. Easy. Multi-cursor is cool. All right, level 9. Binary operator. Okay, we have a bunch that are the same form and then one that's a different form. So let me do this one on its own. Binary operation op is why is it giving me multi-cursor? I don't want multi-cursor. Oh, because I'm doing that key combination. Okay, I need to try to remember that one. That's a useful one. This one. Nope, I'm not doing it now. What was that? It was this. Yeah, to make just to go down and make multi-cursors was that key combo. Okay. Comma LHS box new. RHS box new. That's the in, and then we have all of these ones. So here we'll do multi-cursor because this one is the same form as the one below it. Mostly, except for when we get to the inner one being binary operation. So binary op is binary in, comma, enter, LHS box new. And that's where the difference, oh no, we do have a little bit of the same, right? So box new, expression, binary operation. Okay. Here's where they differ, right? So here it's that, and then that, and then here it's RHS box new. There's one. And then this one is slightly different. CS degree or 12-month full stack bootcamp. Definitely CS degree. The 12-month full stack bootcamp is a lie. They're just trying to get your money. Live in a country in Europe where uni is 100% free. Again, go for the CS degree. Much shorter than a degree. One universal truth in life: the shorter path is not the best path. Usually the longer path is better. Now, that's true for life, but not true for coding. A lot of times in coding, the shorter path is better. Yeah, don't take shortcuts with your life. That's my opinion. Now, make sure you get a second opinion at least. You could do both. Why can't you get into the university, and while you're there also do the boot camp? You're young. You can go with less sleep. Do the boot camp while you're in this. They can actually leverage each other. The boot camp can actually help you pass your classes in CS. The CS courses could help you understand what you're doing in the boot camp. Why can't you can do both. You can always go for some additional side practice while in uni. Yeah, there you go. Why not? Why not do both? Why does it have to be one or the other? I guess it's a good way to say it, right? These are the same, so I can probably leverage that, right? I want to do it very carefully. We'll do it this way. No, it's still going to match too much. I'll just do it twice. Okay, so that goes there, and then this is the right-hand side for the outer, right? Almost. What did we do wrong here? Oh, I didn't have extra parentheses. There we go. Okay, one more. Yeah, missing a parenthesis there is bad. Right hand side, box new. Hold on, I'll get to the chat in a second. I'm super focused right now. Oh, this is RHS, that's a unary operator. And we have to import that. Actually, let's do it this way because it's cool. You won't have time to focus on the bootcamp. Why not? Are you working also? Some lazy. Just kidding. So you're saying all of your time would be taken up by work and university at the same time. Okay, well, can you do the boot camp on the weekends? Or is it on a schedule? So what you could do is you could start with work and uni, and then if the boot camp, well, you said it was a 12-month boot camp, so it's like scheduled. So maybe that's not the best thing. If the boot camp was like go at your own pace, then I would say when you have the free time, you do some work on the boot camp. But if the boot camp has to be scheduled, then I would say, yeah, you have to pick one or the other, do the uni. Maybe you can say, do the uni, and then at the end when you get your degree, if you still feel like the boot camp is useful, do the boot camp after you graduate. 5 subjects in semester was work, attending classes. If you had boot camp, top that would be destroyed. You need to make a choice. Well, you can do one and then the other. Boot camp costs $7,000? You might get to the end of your CS degree and realize you don't need to do the boot camp. Definitely, I think the uni way is better, my opinion. You could learn all that stuff on your own. HTML, CSS, JS. You don't need to pay someone $7,000, especially if you learn how to learn. If uni will teach you that, go through uni. You'll learn how to learn on your own. You'll be able to pick up HTML, CSS, JS, squeal queries, PHP, all that stuff you can do on your own. Maybe the Sass and Bootstrap, you might have to go through tutorials. Scrum, yeah, all that you can learn on your own. You can self-study all this program from boot. Sure, why not? There's nothing secret about any of those things you listed. You could self-study all of that stuff. I think it's just a lot of the times I think that it's sort of like a scam. You're paying someone $7,000 to give you structure. Uni teaches you how to learn in a structured way, and for you it's free. Why would you pay $7,000 when you could do it for free? Yeah. It may be that the bootcamp particular work or small projects or open source activity, whatever student. Yeah. Well, again, it's just my opinion. Bootcamp has advantages of structured programming. Yeah, but uni should have those too. Uni should give you the structured learning, and your mentor is your professor and your TAs. Right? It seems like the same thing. It seems like we're making a choice between a shorter period of time that costs money versus maybe a longer period of time that doesn't cost money and also instills other skills in you that are going to be good for your life. So why don't you just invest in your life? Take the longer path. That's what I would do. That's what I did. Okay, at left-hand side, binary operation. Oh, because this has to be a right. This is not a, no, this is correct. What's wrong with this? Operator. Okay, should be an R and this should be a unary. Oh, because yeah, this is not a binary. This is a unary operation, right? And this is the right-hand side. There we go. I did it. Okay, moving on. Oh, we're done. Run the tests. We passed them all first try. Well, you're welcome for my advice, but just remember, my advice is just one opinion. Ask other people for their opinions too. In your opinion, it's definitely easier to self-study the basic bootcamp program and then some CS classes. Do the CS classes first, because that'll give you a solid grounding and foundation in things. And the bootcamp stuff is more guided, and if you're going to try to self-study it, you're going to be missing the guide. But what you learn in the CS classes can help you do self-study a lot of the same material the bootcamp program would do. So when I was learning, there was no such thing as boot camps. You either had to self-study or you had to go to university. And the universities actually didn't really have a whole lot more than the fundamentals. So like I learned Python on my own. There was no Python class. There was maybe a C class and an assembly language class, and that was it. Okay. All right, finally. Finally, we're done with restructuring our expressions. And I still got time. I got like half an hour at least. So let me go look at my operators at the top here. So we did all that. I guess the next level will be equals and not equals. So that's level 5. Level 5. So copy, paste, rename, expression 5. Make a mod declaration for it. And just to remind myself what we're talking about equal and not equal. So let's go to the grammar. We're going to have an equal and a not equal here. You enjoy coding so much, and when you think of CS subjects in math and other subjects filled with tons of theory, you find them so boring and uninteresting to put enough effort in. It's not like you can't study them, but you can't get into them. That is a problem. It's that you're not motivated to learn them because you think they're going to be boring, right? It's not that you took the math class and you found them boring. It's that you think that they will be boring. Do you see the problem there? If you think that something is going to be boring, you're already setting yourself up for failure. You are not. How are you going to be motivated now to take it if you've already concluded that it's going to be boring and uninteresting? Why don't you go in with an open mind thinking, this might be boring, but it might be fun as hell because I get a good professor. Or maybe you find a way to apply the math and the theory to something practical. Like if it's a linear algebra class, and sure, there's a lot of math in there and there's a lot of theory, but did you know that computer graphics leverages linear algebra so heavily that you could literally learn linear algebra just by walking through an OpenGL tutorial and messing around with computer graphics. You could learn all that linear algebra. Totally. So sure, you could find them boring before you go into them and set yourself up for failure, or you can keep an open mind and look for ways to get you to be motivated to get through that stuff. Understand that when you know the math and the theory, that really helps you understand more advanced things. So you find coding enjoyable? Well, can you code an efficient algorithm? Maybe you can, but if you had a solid grounding in the theory of data structures and like how to make like things efficient at a theoretical level, you'll find it much easier to code that stuff. That's my opinion. Okay, getting off my soapbox again to do some more implementation. Another thing is you might find yourself 10, 20 years from now, like maybe it wears off and you don't really care about coding as much, but having that solid grounding in math and theory, you find that you can apply that to other things besides coding. And now you have opened up your opportunity to a wider set of things that you can do in your life. Whereas if you just did the boot camp, now the only thing you know is how to make a website. You're tough. You're not going to be able to get a job doing anything but that. But get a solid grounding in math and theory. You can do a lot of things with that, not just coding. You don't know, man, 4 years versus 12 months, and your goal is to work as a full stack developer, not much of an engineering role. Why is your goal to work as a full stack developer? Shouldn't your goal be bigger than that? Why don't you set your goal to be make millions of dollars and be the CEO of a company? Or maybe you become an entrepreneur and you found a company doing something really cool in computers. Full stack developer to me sounds like that's an initial goal of that's how you're going to maybe make money in your 20s and 30s. But man, you got to go beyond that. When shoot for something higher. Now, if all you ever become is a full stack developer and you're happy, that's fine. But I wouldn't set that as a goal, you know? That's something you could be now, really. I don't know. I might be pushing in the wrong way. Sorry. Let's see. Not equal to, right? What is Lollipop? We could ask my bot that, and I can talk a little bit about it. It is a parser generator framework. So, backing up a little bit, I'm working on a tool that can take some kind of binary data, like let's say this binary data, right? Now, to us, that might look like this. To a computer, it looks like this. How do we make sense of this? Well, what a computer will do is it will have either pre-coded up or described like this the procedure for how to consume the bytes in order and make sense of it all. So with that, we can make a tool that says the first 3 bytes is the header signature because we said that the GIF starts with the header and the header starts with the signature. So that's what my tool is doing. It's allowing the computer to take a file like this and make sense of it following the specification for what the data means. So there's 3 parts of it: lexer, parser, and analyzer. The lexer turns this into a token stream that looks like this. So it's just identifying that that's an identifier. That's a reserved word there, right? That's a token. That means a separation between statements. That's the first part. Easy, right? Turning it in, making sense of what these things are, what these elemental things are. Second level is what we're working on now, and that's what Lollipop does. It takes that token stream and assigns the semantic meaning behind it. Like, what does it mean? What do these tokens together mean? So we know as humans that this means that's how you describe a GIF file. And this means that the GIF file is going to start with a header. And this means that it's going to end with a trailer, right? But the computer can't intuit that. You have to tell it literally how to interpret this into something useful. So the way we do that is with grammars, which kind of describe how you can assemble those tokens into something meaningful. So it's basically saying, like, if you're in a context where you might need an identifier list, we know it's an identifier list if it's some lists of identifiers with commas between them. And then this allows the computer to say, when I see that pattern, I'm going to say, yes, that's an identifier list, and I'm going to have the vector of the identifiers as the output of that. Okay, so what Lollipop does is you assemble these grammar rules, Bacchus norm, which means that some higher level construct can be described with lower level constructs in a list that are reduced. So when we see this pattern, we reduce it to that. And the whole program, this whole thing that I was showing, gets reduced to one symbol called formats. And formats is a list of one or more format. And each format is a list of statements. And each statement can be different kinds, but like a while loop statement has keyword, parentheses, some expression, parentheses, brace, one or more statements, end brace. And think of it as a huge tree-like data structure in memory that we're going to use then to walk through in order to pull apart the actual bits. We walk through it just in order from top to bottom. We say, well, we start here. The first thing is header. First thing is header is this, which means that the next 24 bits is a string, and we're going to call it signature. And that's literally, it says, okay, parse the next 3 bytes, call it the GIF header signature, and that's its value. So hopefully I didn't lose you along the way. Lollipop is a Rust crate that allows us to describe a grammar for our language. And given that we can turn the input language into a stream of tokens, this spits out a data structure, which is the compiled form of that. Yeah, I'm building a compiler. The first 2 of the 3 steps I just described is literally a compiler. It's compiling this program, so to speak, into a data structure in memory, the compiled form. So a traditional compiler, that abstract data tree is used to generate code, right? You visit all the nodes in that abstract syntax tree, and you generate a program as your output. For me, it's a little bit different. Instead of generating a program, we're using it as a recipe to parse these bytes into this output, right? So it's almost like an interpreter, not a compiler. When you think about it, it's interpreting the bytes of the GIF file using the program we gave it to say what each of the bytes means. So it's very similar to like a dissector, a data dissector in Wireshark. You get this packet on the internet. What do these bytes mean? Well, when you click it, some code has to say these bytes match up with the definition of some protocol. In this case, it's Ethernet. And okay, then we know that the first 2 bytes identifies that as an Ethernet packet, and then the protocol type, etc. So kind of like the same thing. All right. We're working on the grammar for expressions right now. So it's kind of complicated because expressions have different operators with different levels of precedence, and we have to order them from least precedent to the lowest precedence to highest precedence. So highest precedence would be literals and things in parentheses, and then the unary operators, right? And then the lowest precedence would be like, well, like we're doing now, like comparisons. So the math stuff is higher precedence and the comparison stuff is lower precedence. With file formats I'm planning on supporting, it's not so much that I'm going to support them, it's that whenever I get interested in looking at a kind of file format, I'll probably write one of these. I'm only using GIF as a demonstration. So like, for me personally, I think eventually I'll use this to look at the formats for saved game files. So I was working on Twitch like 2 or 3 years ago on making a game, and that game has objects in the game are written as like little files, binary files. At first I was using JSON, so I didn't need one of these to read it. I could just open it in the editor, I could see it. But it was really slow, so I was moving to a binary format. And some of these binary formatted objects were being sent across WebSockets. And I'm like, well, if I have a bug, I can't really look at that stream of bytes and make sense of it. But if I had a tool like this where I could describe what my game objects were and how to parse them, then if I capture some packets when the game is misbehaving, I could use the tool to look at that and say, okay, now I see that it's transmitting these certain objects, and oh, there's a bug there in how I'm encoding an object. So I might use it for that. But it's really open-ended. Whenever the need arrives for me to look at some kind of binary data and I can describe its format, then this tool will help me analyze that. It's like making our own tools, right? For future use, we don't know what we're going to maybe use them for. So making it general purpose. Now I've kind of lost track of what I was doing. Did I have everything built? Yes. Okay, so then I guess it was expression 5 I was working on? Yeah, okay. Because that is copied from 4 right now, right? Yeah, okay. Then I think I was on the grammar file. I need to add expression 5. Oh, that was equal, not equal, right? Yeah. So 4 becomes 5. 3 becomes 4 here. And then we can drop 2 of them, because level 5 expressions are equal and not equal. Okay, and then we have to, oh yeah, I added those. So those are already there. So then I just need to update the test to match this, right? Can you write a format like that for vids? Yeah. So the way I would do that is I would go pick a favorite video format. So maybe your format is H.264, otherwise known as advanced video coding, right? So somewhere there is a document online. You might have to pay for it, but if you search long enough, you'll probably find a free version of it that defines the format for this kind of video. And then it would be a lot more complex than a GIF, but you could, if you were dedicated enough, write the syntax for all the bits in a video. You would pick apart how many frames there are, and within the frame, how many pixels wide and tall they are, what the frame rate is, how the pixels are encoded. Maybe there's compression, so you have to decompress it first. Maybe it's encrypted and you have to decrypt it first. But like ultimately, every bit in a video will mean something, and it will have to adhere to some kind of format because video players use the format standard to be able to decode and show a video no matter who made it, right? That's what standard formats are. That's why they exist. It means the video is written in a certain way that anything that supports that format can read it. So if we were to write our own copy of that format for our tool, we'd be able to read the videos too. I don't know what this is going, but yeah. You have to know what kind of format it is though. So vids, you'd have to look and see what format is used. I think AVC or H.264 is pretty popular. MP4 is also pretty popular. And there's a new one coming up that's also gaining in popularity. I think it's AV1. Is that right? AV1? Yeah, I think this is it. So it's the open royalty-free successor to H.264. If you're into like video files and formats, this can actually be a pretty deep and fascinating topic because when you see how the progression in history, like why these formats were made, like really old one would be like MPEG-1, right? MPEG-1 was invented for, I think, CDs, and then they made MPEG-2 for DVDs, and MPEG-4 was used, and H.264 were for Blu-ray. They made them to solve specific problems, right? How do you fit a video onto a medium like a compact disc that can only hold so many bits, and it has to be a certain length? Most movies are 2 hours long. How do you fit 2 hours of video onto a compact disc? These formats were invented to solve those problems. So AV1 was invented to solve the problem of video on demand and achieving certain data compression ratios. So if you're first learning this stuff, go to an old format like MPEG-1. Learn that first, and you don't start with the cutting edge stuff because this is super complex. They're complex because the problems are a lot harder these days. How do lossy formats work? There's whole books to describe that. Here, I'll give you some things to look into. Lossy format. Look up discrete cosine transform. Now, hopefully you're not afraid of math because you can quickly get lost in the math behind this, but DCT, discrete cosine transform, is like one of the foundational ways you get very high compression ratios for lossy technologies like JPEG, MP3. All these are based off of discrete cosine transform. So like it says here, it's similar to a discrete Fourier transform. So we're talking like pretty high level math stuff. But you can find like other things. Wikipedia is not the best thing to learn something new, but you could probably find guides out there on the internet that give you a more approachable introduction to this. And then this gets you into like, well, what are the building blocks of making lossy file formats? Is this used by Twitch? Probably, because doesn't Twitch use MP3 or AAC for the audio? And they probably use either H.264 something or MPEG. So MPEG, H.264, they're all built off of DCT. This is a building block, a low-level building block. Now something more whole, like encompassing, like Twitch has a lot of things. Like there's the video aspect of Twitch, there's the audio aspect, and then there are different formats probably that Twitch supports, and so a lot of different pieces. And this would be like one of the low-level building blocks that's used to format that stuff. There's literally huge 1,000-page long books that go into this, and there's no way I could describe it very well in just talking about it. Did I run this to make sure? No, it's not going to work because I didn't change this. This still says less than, but we want it to be equal. Also, this expression 4 needs to be an expression 5. All right, so this is equal and then not equal, I guess. And we don't have 4 cases, we only have 2 for this level. Okay, let's see if I missed anything. Yep, of course. I get distracted by chat, which is fine. Yeah, we didn't define what the tokens mean. Wait, no, I did. Oh, binary operator doesn't have it. Okay. Operators, we don't have equal and not equal. And we pass. All right. Hold on. Gotta adjust my seat. That was expression 5, which is here, which is equal and not equal. So if I'm look at my list again, the next would be right. So we're gonna have like 3 grammar rules for the logical. No, these are bitwise operators, right? Inclusive or, exclusive or, and, which is mask. It's easier to see that if we look at the lexer form of that. I not have it open? I do, but it was here. Yeah, mask is and. Inclusive or is a vertical pipe. Exclusive or is hat. All right, let's do it. So then that's copy paste. Expression level 6 is mask, right? Not 66. So expression 6, we have to add it here. Okay, so then 6 goes here. And we have mask. And only one test case needed. Easy. Okay, so let's do the operator next, since we were just there, and we have mask here. And then let's do the grammar part. So it's just this is all we need from that. Expression 5 becomes expression 6, and oh, I need an expression 5 here. This becomes a 5. And we turn that into mask. All right, I need to add that down here. Mask. Token. Mask. Pass. All right, on a roll. Next after mask. Exclusive or. Added here. Exclusive, right? Operator exclusive or. And the test, well, let's do the grammar first. That's level 7. So 6's become 7's, 5's become 6's. Because these are all left associative. So that's exclusive. Cool, and then the test. So we'll copy 6 to 7. You can kind of see where this is going, right? We'll have a 7, we'll have an 8, and then we'll be done. Well, actually, there's a 10 and 11. Because I skipped to 9 before. Because I do that sometimes. Okay, so 6 becomes 7. Mask becomes exclusive, and I think I'm done. See if I missed anything. I don't have a good track record, but there I did it first try. And then the next one is inclusive OR, right? So let's just copy, paste. Since I'm on a roll, this will go quick, right? 8, 7 goes to 8. Exclusive becomes inclusive. Done. Operator. Operator needs inclusive. The grammar, we need inclusive as a symbol. Okay, and then level 8. 8. And then 6 goes to 7. Exclusive becomes inclusive. Pass. Wow, that went really quick. So then I have all of these operators done. The only ones left are the logical and logical or. Let's get them done, because then we'll have all the expression done. And then that opens the gate for a lot more grammar rules. So yeah, let's do it. We're almost done with expression. Well, we're almost done with the operational expressions. I still need to have like the non-operational expressions. Let's copy 8 to 10. Oh, you know what? I've never been running I haven't been running the tests for 7 and 8. That might be why it passed, because we were never actually running it. Okay, well, hopefully the tests were fine. We're just gonna hope that they were fine. So 10, I forgot what 10 was. Logical and. How do you like Rust or Zig for hardware programming? I'm glad you asked me that, because see this keyboard here? I designed and built that last year, and I wrote all the code for it, and it's all in Rust. So that's hardware programming. I had a blast. I didn't have to do everything bare metal. I based it off of some crates that the community had put together for the microcontroller that I picked, which was a Raspberry Pi microcontroller, their first one, the RP2040. So I didn't have to figure out like how to set up the CPU or how to do the USB stack. Those came from the community. I just made those pieces fit together as a keyboard firmware. I haven't tried Zig, but yeah, Rust was really nice in that it was easy to cross-compile for this microcontroller. I didn't have to set up anything special. I just told Rust that, hey, I want an additional target. I want the target for the CPU. There was a little bit of weirdness to set up like the workspace so that I build the firmware for one target and the control program for another. But it wasn't nearly as bad as like trying to do that in C. Sorry, talking for like 2 hours is hard on your throat. Okay, so the inclusive becomes, I forget now. This is what happens. And here's where I think that might be a reserved word. Oh, also there's no operator for that. And now there is. Okay, we need to have a parser, a grammar at level 10. Okay, so the 8 becomes a 10 and the 7 becomes a 9. And that's and. Oh, and now that 10 is the top, this one has to be a 10. Okay, so now this should actually work. Cool. Okay, and then this should work. Okay, we didn't pull in the symbol for and in the grammar. Down here. "60 tests pass." Okay, so then there's just logical OR, right? So let's copy 10 to 11. Remember to actually declare it, otherwise it won't actually run it. All right, and then in here, 10 becomes 11, and the and becomes OR. Binary operator has to have an OR in it. This is looking more and more complete now, right? Has all the different binary operators you might want, and even some unary ones. 11. So that means the grammar is missing. Well, since we're here, let's add OR where it should go, right here. Okay, and then we're talking about expression level 11. We have 11 levels of expression. 10 is 11, and 9 is 10, and is OR. And then I can't forget to change that to 11, otherwise we'll have trouble with parentheses. In a similar test files, you can't write more generic. That's what Sarian in chat was suggesting that I do earlier. And it's probably a good idea. The differences are in which operators are at what levels. So somehow I still need to encode this information from Bison, right? The fact that some of these are left associative and some of them are not associated left or right, and some of them are right. And then the order, the fact that OR is the least precedent and left shift, right shift are the most for binary operators, right? So I have to encode this somehow in the test. That's what makes the test different. So I encoded the order simply in the grammar by having using numbers, right? And having them in a nest in a certain way, right? So the 11 has the 10 has the 9. So that encodes the order. How do we test that order? It would be that we actually make strings of operations in a chain and then make sure it does them in the right order. I did a little of that, but not a whole lot. I think I did that at level 7 or something. But yeah, some of the stuff that's repetitive, like the fact when a standalone binary operation should take a left-hand side and a right-hand side in an operator and turn them into a binary operation. Maybe we could write a macro for that, because the only thing different here is that token turns into an operator. And the parser we use is different each time. Actually, although we could use the expression level 11 parser for all expressions because it is the top level. So I could make that the same. So yeah, the things that would vary would be what's the token and what's the operator, because there's a one-to-one mapping that we need to test. Problem I think I would have is I'm using the test case crate, and that is a macro, and I'm not sure how to make a macro of macros. Let's say I knew how to make a macro of macros, then I would have something like test. I would have something like more specific, like binary op test, right? And it would have something like, this is what the way I would do it. I would have token OR, and then I would have binary operator OR. In fact, if I knew that these were the same, I would get rid of these and just say OR, right? And then that would generate all of, whoops, I didn't mean to click that. That would generate all of this, because that's the only thing that's different about the test, right? Maybe I would also have to say that it's, well, no, we would bake in that it would be the top level. So let's leave that for later when I get better at making macros. If I can make a macro that generates all this, then that's how I would do it. Then I would have one file which actually has everything in it, you know, all of this, you know, etc. I would do it that way. But I pay the price for not being very good at macros by having repetition. It's not too bad, and I think we're done with it. Right? This was building still. 61 tests now. Grammar. KKKKKK. So, okay, let me look at the expression rules to see if I got them all. So an expression less than or equal, not equal, greater than equal to, minus, plus, divide, modulo, multiply, left shift, right shift, or, and, inclusive, exclusive, or, mask, in, not, flip, minus, the parentheses one. Okay, so we did all of those. We did all of that. So I'm just missing function call. So I'm missing all of these. Function call, literal map, map construction, literal set construction, literal vector, vector construction. Attribute copy. I didn't know I had that. What is that? What's copy? Is it just the word copy? It is. It's the word copy. Attribute copy. Copy in something in reference. I don't even know what that does. Should I look in the C code and see what that does? What does this do? Let's look in the decomposer. What does it actually do when you get a copy expression? Okay, it dereferences the reference to get the original reference. It's nothing if it wasn't a part. And if it doesn't have a value, it clones that value and returns it. And if it is null, it extracts a value from the component, which is, I don't remember exactly what that does. Returns a copy of the given component's value or a map or vector containing copies of the component's subcomponents if the component's value is nil. Huh. I don't remember doing that. I don't remember this at all. Interesting. Where would I use this? It's in expression context. I guess I could have used it back here. Some of this conditional logic stuff. Like this, right? Well, no, that's not right because this has to be transformed. It can't be copied out. Where did I actually, was it LEUI? Here. Well, we still have to transform it. Where's something that I wanted to reach into it? Was it, maybe it was data header. Maybe that was it. Yeah, this one I constructed a map myself. Maybe if I used the copy of the data header, I would have gotten the first and second. Where do I use data header? Use it there. Right, I did a look ahead and made a copy with that syntax, and then looked it up as a map. I guess this is where I could have used copy. I could have said, instead of doing that, I would have said copy look ahead first. Huh. Okay. Well, do I port it over because it's there, or do I forget it for now? And what's the operator precedence of copy? It doesn't. It's not. It's not considered an operator. It's considered a token. It's a non-operator. Wait, I said the word copy up there. Oh, that's if there's an L value part. Okay. I think it's because you have parentheses here. That's what I had to have the parentheses there because otherwise that would need to be an operator. Actually, I could turn it into an operator by assigning it a precedence, and then I could remove the parentheses, right? It would be a unary operator, which gives me a copy of some reference. Anyway, there's reference lookup, which we don't have yet. And we have literals we've done. So the ones that are missing here are references, copy, attribute copies, vectors, sets, maps, and functions. Function we could do because, well, no, we can do expression list next because expression list is used in a bunch of places that we need, right? And then maybe after that I do references. How much time do I have? I don't want a recreation of that time where I missed the beginning of my meeting because I thought it was at 10, it was really at 9. No, my meeting's at 11, so I'm fine. Yeah, let's do function calls next. So then, what should I name the test then? It technically is an expression. Maybe like expression underscore function or something like that. Yeah, let's do it that way. So I guess it doesn't matter. I just copy from 11. So this is expression function. So it's going to be an expression. Actually, this would have to be higher level than the operators, right? How does that work? No, lower level, right? It has to be an expression 0 thing. Yeah, we have to put them all in here. All of the things which are not operators. I think they call them in his tutorial, the guy who made Lollipop, he called them terminal expressions. I'm calling them expression 0. So I would just lump them all in here then, right? That means I don't need a expression function. Delete. I would just put it into expression 0. Didn't mean to do that. Okay. Yeah, we can put it here. So just another test case. So the test case would be yeah, doesn't really matter. The test case would be we have to have an identifier, right? And then a left parentheses and oh wait, hold on. I needed expression list first. Okay, we'll get back to that. I need expression list is what I need. So copy paste, I guess. Expression list. List of expressions. So it's going to be a vector of expression when we get out of this, right? Okay, expression list. Actually, you know what would be better is to copy from like op list or ID list actually. Let's copy from ID list into expression list. That's closer to what I want. So ID list becomes expression list. So instead of identifiers, I would have expressions. So a token for an expression, actually that is a valid expression, right? So we would get back out not a string, but we would get an expression, a expression, identifier. Do I have? Oh, that's a reference. So we can't use that yet, but we'll be able to use it later. So we'll just put literal integer. It would be integer, right? 42, because I like the number 42. So that's an expression literal integer. 42. And a vector. So that's one expression. And then we have two expressions. So let's just kind of copy paste here. And we'll just make this some other number, 67. So then we have two literal integers. That didn't quite work out. So I'll individually paste over them. 67. And then we have two. Do I really care about the too many tokens thing? No, let's keep it simple. Invalid token, no. This is an interesting one. I think we want to keep that one. Use crate expression. Right, so we change that to be, we expect a vector of expressions. Okay, almost there. So then comma and then some integer should turn into just the integer. We're okay with the extra comma in front, I think. Okay, and then the empty is easy. So then we have expression list. Okay, so then I just need to have the grammar in place. Grammar. Do I put expression list after expression in the original grammar? Where did I put it? Exper list. I put it before expression. Right before. And we're also going to have optional expression list. Yeah, so an expression list, it can either be empty, a single expression, or a comma separated list, which implies that this can match the empty rule, which means we can start with a comma, which is kind of bizarre. I should probably rewrite this so that the comma goes after the expression. Then it's like it allows a trailing comma, but not a beginning comma. Hey there, Flask. We're doing grammars today in Lollipop. Yeah, so we're going to describe it up here, right? Pub exper list gives us a vector of expressions. I'm going to copy from ID list because that was pretty close to what expression list is going to be, right? It's just that the type is different. So instead of ID here, it's going to be E for expression. You know what I would like to do is let's have a rule to package the current top level expression like this, but we don't need to have a test for it because it's really just a placeholder so that an expression is an expression 11. Then I could use the word expression here and I don't have to remember that it's 11. Okay, so then that's E. So an expression list, comma, another expression. pushes that expression into the list. Writing a code to construct a parse tree from tokens supplied by the lexer. Yep, I am. Here is the lexer right around somewhere here. Here it is. Lexer is written in Logos as an enum with a bunch of attribute macros to define subpatterns, our white space, what are our special tokens, our reserved words, our literals, operators, strings, that kind of thing. Very cool. Writing a compiler for a language I made for describing how to study data. So you could use my tool to pick apart the elements of a GIF file by describing it as a header, followed by a logical screen, followed by 0 or more data blocks, followed by a trailer. So when you run it, it looks like this, right? If you were to compare that to an actual GIF file, which I have here somewhere, this one. Here's the actual GIF file. To us, it would look like this. To computer, it looks like that. First 3 bytes is GIF. We know it's a signature because of the format. Version. Then here's the first part of the logical screen, which is the screen width, 300. The lexer uses regular expressions, yeah. Most lexers do because lexical analysis is very close to regular expression analysis. In fact, you could almost say that a lexer is a subset of a generic regular expression engine. But it does additional work. So a lot of these will have a callback, right? Like, for example, integer base 10 has a callback, and what that callback does is it calls parse in Rust on it. That's easy, right? But what if you had a base 10? Well, we have to do a couple things because the way I describe base 10, there's an X in there, and parse doesn't like, in Rust doesn't like to see that X. It likes to just be told that, hey, it is radix 16, right? So I have to do a little bit of stuff to strip out that X because there may or may not be a sign in front. We have to pick apart the sign from the actual digits and apply the sign separately. But yeah, so this is what is in addition to the regular expression here. The regular expression kind of selects the slice of the input, and then the callback that the lexer adds to that is it's adding, like, how do you transform it into a token, right? So you could make a huge regular expression could be made to match different elements of this program, but that's all they would really do is match. The lexer takes those matches and transforms them into a token list. So that looks like this. For example, identifiers, we just retain the original string. Operators like this left brace go straight to a token. There's no data associated with it. It really is just a variant of a token. When we get to like a literal though, that gets consumed somewhere in here. You guys see it? It's around this next equal. Here it is, integer 59, right? That's because this went through that callback that after it matched the character 0x3b, it said, okay, interpret that as a hex by stripping off the x, and the sign in front is, there's no sign, so it's positive, and then interpret 3b as a radix 16 integer, which is 59. That's what a lexer does. It's all regular expressions and then callbacks on that. And to get the parse tree from the tokens, that's where we have these rules. They're called grammatical rules, otherwise known as a grammar. So I'm building from the bottom up, so we're not seeing the top down. But if I were to show you the top down from the C version of this, I have too many files open. Here we go. At the very top, the entire file is a sequence of format specifications, right? And the way you do it in a grammar is kind of weird. You form chains because these are shift reduce rules. So like you shift in tokens until you can reduce a rule, right? So you start with empty, so that establishes that you have an empty formats to begin with. And then the next format you see, you chain it to the end of that empty one. And then that forms another formats, which then you chain another one on until you, so it's like forming the links of a chain from the beginning to end. And then this special rule is if you have an illegal token, that you actually print the location of where that was and the fact that it was illegal, and you error out. You always end up with too many file tabs. Yeah, me too. We can actually close a lot of these. Like, I don't need these ones like I don't need these, right? Just close them here. I want to keep some of these because new people come into the stream and they ask me what I'm doing, and then I have to like say, well, here's the data we want to parse, and this is how we describe how to parse it. And yeah, so I want to keep those up. And like, here's how the lexer is defined. Oh, we don't need this anymore. We do. We do need it. We're making a new kind of expression soonish. Actually, I guess I don't need it now. We're done with operators. Woo! Yeah, so there, I've reduced my tab count. Okay, expression list was here. That's done, right? If I save that and I go back to here and hit save, now it should work. Let's see if this actually just works. First try. So somewhere in there is going to be expression list. Here we go. It passed. Nice. So expression list allows us to get vectors of expressions out. So that would be like arguments to a function. So then I think the next one right after that was like optional expression list, which is just building off of that and saying we could have nothing or something, right? Down here somewhere. Right. There's expression list. Here's optional expression list. It's either empty or we have expression list in parentheses. So that was a lot like optional ID list. So let's copy from there. So then I guess we put it here. Optional expression list. And that's it, right? I just need to have a test for that. So let's copy from op ID list, and we'll make the copy op expression list. And remember to put it in here. Okay, and then ID list needs to be expression list. Okay, yeah, I can't use identifier because I don't have reference expressions coded up yet. So we got to replace all of these with token integer, right? 42 or 40 or whatever. And then that turns into, instead of foobar string, it turns into expression literal integer 42. Okay, so we need to import expression. Yeah, so the expectation needs to be that we get a vector of expression out. That we did add that, so why is that not a given? It just needed to build it. No, we're missing something. So we still have string in there somewhere. Expression. I don't see it. Expected output. Oh, is it in the grammar it's wrong? Oh yeah, look at that. That should be expression. Yeah, okay. So that's probably it. So something's different. Oh, right. Yeah, that I don't really want to get involved in. Yeah, all these extra tests I put in there, I think I want to remove them. Because there's just too many like expecteds to care about. Leave that the subject of the expression test, right? Right paren missing. Yeah, it's the same thing. Like we could be expecting a lot of different things. Cool. Yeah, just delete their tests that fail. Perfectly legit strategy. Okay, where am I in the list of to-do things? We have expression, we have optional expression, we have expression list. That's an optional expression list. Do we have an optional expression? Nope. Okay. Okay, key value is an interesting one. That's where we have two expressions with a colon between them. And the type is a literal map because that's just a single entry literal map. I actually don't think I need to reuse the data like that. Spacetime DB, thank you for the raid. Hope you had an awesome stream. If you're not needing to leave right away, maybe you can talk about what your stream was about while I talk about mine. You can type and I will talk. So I've done this enough times now in the last 2 weeks that hopefully I can do this in a pretty straightforward way. We're writing a tool that is able to like take any kind of binary data and like tell us what it means, similar to what Wireshark does for protocol analysis. So if you know about Wireshark, it's a tool that you can have it look at your network and like it can listen in and see the packets that are going across the network, and you can actually click on a packet and get like really detailed information about what's in there and what the things mean. So these are called like data dissectors. They take these bytes and they interpret them, like figure out what they mean. So I'm writing a tool that's like that, where you could feed it in data like this file. To us, it looks like this, but to computer, it looks like this. And the way my tool works is it's a compiler coupled with a data analysis, data traversal tool. So we first describe the format we want to parse using a domain-specific language like this, right? A GIF file starts with a header, ends with a trailer, and it has some data blocks, and it has the screen descriptor in the front. The header is a 24-bit string signature and a 24-bit version string. So the front end of my tool will compile this description into an abstract syntax tree, and then the back end of the tool does an in-order traversal of that tree along with the actual data bytes to generate an analysis. So it looks like this. So it'll say, yes, the first 3 bytes are the signature. The next 3 bytes are the version number. The next 2 bytes here is the width, and so on. Yeah, and I originally wrote it in C, and I'm porting it to Rust. And you are writing bitcraftonline.com in Rust. Or spacetimedb.com. Nice. Did I make my own DSL for the tool? Yes, I did. And there's even a DSL command. So yeah, this language, like the command says, describes how to parse the input data bytes. So my goal right now is to make something that looks like Wireshark, but instead of being focused on protocol packets, it will be more for like you drag and drop a file in, and then you drag and drop the format in, and then it gives you a breakdown of all the things that are in that file. Have you thought of using Antler? I like made this tool like 5 years ago, probably before Antler existed. So I didn't even know about it. Now, let's say Antler does everything my tool does. I could just use it, but since this is a hobby project, it's kind of fun to make my own thing. Even if Antler could do what mine does, I'd still probably work on this just because it's fun. Backend of Bitcraft is written in Rust. Nice. So the backend of mine is written in Rust. The front end stuff, we're leveraging some Rust crates. So the first step of a compiler is to do the lexical analysis, which is you take the lines of text and you turn them into a token stream. The tokens are an enum in Rust. Each variant of the enum is the kind of token. So like this is an identifier, and then that's a basically a symbol called left brace, and header there is an identifier. The second stage is to take these list of symbols and like assign semantic meaning to them and form the abstract syntax tree that like this represents. Like GIF is the top node, and then we have child nodes, header, logical screen, etc. And then we would use that structure to walk through the data, right? So the lexer in the C version, I had written it in using flex. So it's a bunch of like regular expressions and strings, and then how they map to the tokens, and then what data to assign to the tokens. In Rust, we're using logos. And what's really cool about that is you the derive for logos generates the lexer based off of all the attribute macros you attach to it. So that's how we do white space. That's how we do sub patterns that we can now use in our regular expressions. And we have callbacks for the regular expressions to interpret the string. So we would actually do the string to integer conversion in these callbacks. So they look like this. So we leverage Rust's parse function and from strradix for like the hex and the octal and all that stuff. And yeah, I think it's cool. That's why I'm working on it. I'm glad you think it's cool too. So the lexer's done. The parser, we're using Lollipop. Kind of a whimsical name, right? Because LALR stands for look ahead, left, right. The way you do it is you describe your domain-specific language using a list of grammar rules, and then you would have like a top-level grammar rule. For mine, I haven't ported it yet, but the top-level rule would be formats, which means a sequence of format specifications, right? Because that's what this is. This is one format specification, here's another one, so it's just a sequence of them. That's the language. And grammar rules are Bacchus-Nor form, which means there's the output symbol, I guess you call it, or the output node. There's the output node, and then there are the rules that will reduce to that node. So you can either have empty input, so that's fine. If you have an empty file, it's a formats with nothing in it. Or you can have another format, so you can recursively nest and followed by a single format. So if you had like one format, it would be an empty formats followed by one format, right? And then this chain. So if you had two formats, then this one matches this rule, and then the second one is added onto it. Yeah, and then the rules build on each other. So format is itself a syntax rule. And the parser generator's job is to like match the tokens that come in. These tokens come in and like find the grammar rules that these match to. And you're doing a sequence of shift and reduce operations. You're shifting in a token, you're shifting in another token, you keep shifting until you finally actually match something. And then you say, oh, I can reduce that to one of these higher order syntax rules. Reduce it. And then you try to reduce as much as you can. When you can't reduce, you shift more in. If the program's valid, you end up reducing everything to a formats at the end, and then you have this nice data tree. Isn't it so much a nested closures in Antler grammar? Probably, because this is following general compiler theory. You have a recursive tree from the parent. Yeah, you got it. Synbleed has it. I learned this all from the Dragon book. Compilers, principles, techniques, and tools. I actually have a first edition copy of this in my garage. I'm never letting go of that book because that was the most awesome book for learning this stuff when I was in college. So there's actually a second edition of it out there, and I'm sure there are other ways to learn it, but the fundamentals have remained the same for like ever. You do lexical analysis, and then you assign semantic meaning to the tokens, and you end up with an abstract syntax tree. Glad lull isn't a left tail recursion bug we need to fix. So, grammars in lollipop. What's kind of interesting about that? Pop, of course, whimsically to make it sound like lollipop. You get it? I just ruined that joke forever, didn't I? It is a Rust code generator. So you feed it something that's kind of like a mix of plain Rust and then like an amalgamation of Bacchus-Nor form syntax rules that have Rust in them. So, for example, op ID list. The way I used to do this was with Bison. You would have a rule with, you'd have a syntax, you'd have a grammar with two rules. Is that how you, am I using the right words? You have two ways to have an optional ID list. You either have nothing or you have an ID list in parentheses, right? So the way we do it with lollipop, it looks like a match statement. And the left-hand side is a sequence of basically what, like either terminal symbols or other grammar rules. And then the right-hand side is when you reduce that rule, what is the output? So if you reduce nothing, you get a none for your option. If you reduce an ID list in parentheses, you get the ID list that was in the middle out of that. And it's as some ID list. So ID list is where it's not optional. You're going to have an ID list. See, if you have nothing, it's an empty list. If you have one identifier, it's a vector with one thing. And then if there's more, then we're using this recursive rule, right? You either have you have one more identifier with a comma before it, and then the chain in front. There is a really interesting peculiarity in my language. The comma is before the ID, which means you can have silly things in my language that are perfectly valid, like I can put a comma there, and that it's perfectly valid. I can't do a trailing comma because of the way I wrote the grammar. But if I rearrange this to allow a trailing comma, it would work. Trailing comma doesn't work because whenever we have a comma, we need to have another identifier, right? So there's no identifier there, it would be a syntax error. But preceding comma works because ID list itself can be empty. So you could have empty followed by comma followed by ID. Isn't that interesting? So just the way I wrote my grammar, I allow preceding commas, but not trailing ones. Laugh at my own consequences of my own early decisions. So I'm not fixing that. I'm trying to like port as is the C to the Rust. We've gotten maybe, I don't know, a quarter of the grammar rules, and I'm just kind of building up from there. One thing you're looking is using type systems for type inference using a single AST. Okay. That sounds cool. Okay, where was I when the raid happened? I don't remember. Let me make sure that our tests run. Okay, tests are running. Actually, now that I haven't done this in a while, I need to send my code out of the virtual machine so that if I screw anything up, it's sort of backed up. Okay, yeah, I'm not using version control inside the virtual machine, but I am using it outside. I think what I was about to do, now that I had optional expression list, is I was going to do a key value. Right, because a key value is just one expression colon another expression. See, let's do that. So, test-driven development, right? We would have, it doesn't really matter which of these I copy, right? What if we take op expression list, make a copy of that and call it key value, and then in tests we'll declare that we have a mod key value sort. Okay, and then key value. Instead of expression list, it's key value. So you have the key value parser. So that would be like two expressions, make them different, and have a colon between them. We expect out of that a new kind of thing, which is a key value. And that will have two expressions in it. Literal integer 42. So two ways I could do this, right? I could have the key value be a tuple by adding extra set of parentheses and then a comma, and then I can have the value here. That's one way I could do it. The other way I could do it is I could have curly brace and then give these names like key and value. I'm tempted to do it this way because it's much easier for me to remember which one's the key and which one's the value, but tuple is okay too because traditionally the left one is usually the key and the right is usually the value. BNF production rules are fun. They also drive you mad, but they're fun. If you have a shift reduce or reduce ambiguity, they can be really maddening. That's true. But I have an advantage. The advantage I have is that this syntax is already non-ambiguous for Bison. I just have to make sure when I port it over to Lollipop that it stays unambiguous. Got the Dragon Book after implementing that. First thing you did was find their production rules and compare to how you implement it. That's always fun. I do the same thing with some folks in my chat will write their own or have already written their own versions of things, and then they'll share the links to it, and then I'll like see how they did it. Especially when we do Advent of Code. To see how other people solve the same problem is always interesting to me. Because I find that I end up writing brute force solutions more than other people. Other people are more thoughtful and will have more elegant, faster ways of doing things. What if we go with this for now? I don't think I want to handle the negative case for now. And there is no empty test. So we're just going to keep this. Oh, this is not optional. It is not an optional key value. It just is a key value. Okay, and then the output is a key value. Okay, so I need to have a type called key value. At the same level as like expression. So let's make a new module called key value. RS. I guess by convention we want to underscore that because we're going to end up doing kind of similar to an operator, right? We're going to have derived debug and partial equal, and this is going to be a type key value, and it'll have two things in it. The key, and I have to make these public, don't I? Actually, what am I doing? It's not a struct. Hold on. Yes, it is. Because it's unlike expression. Expression used variance where that's like an inner type, but we're not leveraging expression. This is standalone thing, right? Yeah. So I think I actually have to name that public, don't I? If we want it to be usable outside of here. Let's confirm that by leaving it not public, and we'll see it break. Value is also an expression. So then we need to import it, or we need to declare it. An expression will need to be imported. Okay, and then here, let's add this key value. And here's probably where it's going to say, oh, it needs to be a vector. Oh, yeah. No, it's not a vector. There's no vector here. There's also no sum. This is just OK key value. Why does it need to be sum? Because I have option here. It's not option. It always is one. Okay, here's where it needs to be public, right? Field is private. That's what I thought. I used the multi-cursor thing. That was cool. Okay, and then in our grammar, let's put it in there. So pub key value gives us a key value. Mistyping. Go slower if I mistype. The key value we need to import. I should try, because the sorting is not automatic for this, because it's not really a Rust file, that I should try to do this manually. Okay. Okay, key value. Back here. Yeah, it's just expression colon expression. So key expression colon value expression maps to key value. Key is key. Value is value. I think that's how we do it. Oh wait, no, I just use it as is. I don't need little tick marks. I needed the tick marks where I declare tokens. Now, I don't know if I have colon. Let's see if I do. I don't. It goes here, right? Colon. Cool. So just run the test, right? It just works first try because I'm awesome. Yes, it just worked first try. So where was that key value? Look at that. It just works. We are awesome. Okay. Hey there, next programming. Here's where our DSL looks like. It's used to describe binary data. I'm using GIF format as an example, but it could be any kind of format. Modeled after what we have for in Wireshark for protocol dissectors, right? Dissectors. That you can describe what binary data means, both structurally and also functionally. You can say we parse it from first byte to last byte, and we declare what the pieces are in order. And we can have loops, which turn into vectors, and we can have conditionals. So we can break out early, or we could skip. We can have alternate structure. I think it's beautiful. Thank you. This still thinks we have an error, but I bet if I save, the error goes away. Yeah. Its Rust analyzer hadn't caught up to us. Okay, so we did key value. So with key value, then I can do key values, which is a special expression with two expression chains held. Well, we don't have to do it that way, right? So it's just a comma separated list of key values. That's all it really is. Yeah, I did some complicated double-ended linked list stuff here that I don't need to worry about in Rust because we can just use vector. how about we copy expression list, and we'll name the copy key values. And then here in expression list becomes key values. And the type that we get is a vector of key value. And then the cases here, 1 key value, 2 key values, probably use it to discover structures in an unknown or poorly documented binary files that cleanly have some kind of structure and many other things. Yeah, there's a viewer of my stream and also Adam's stream named Ramy, and he's been reverse engineering Digimon formats. And I've been talking to him about like this would be kind of a cool thing if I had it ready. He could actually use this to like reverse engineer the formats and inspect them pretty easily, right? I don't think I'm going to cover these test cases. We do want empty though, right? Do I actually want that? No, yeah, we do want that because we allow extra comma in front, right? Because we're weird that way. Okay, but I need to change these. These need to be key values. So it's like that and then a token colon and then another integer or something. Just something, some easy expression, right? So like 67. So we get out a vector with one thing in it, which is a key value where the key is that. Okay, I have to start thinking about time because I probably should wrap things up and go to work. So that's one key value. And why don't I copy that? Because that's really convenient because we're going to have 2 here, right? So a vector with 2 key values in it. Let's just use different integers. So that's 1 followed by another. 1, 2, and 3, 4, and we're done. Okay, and then we're going to copy this because like here's the other alternatives. We have a comma before that, and we end up just having this 1 key value here as the result. Cool. So let's write the syntax, the grammar for it. Grammar rule. So pub key values is a vector of key value equals some stuff. And expression list was a good one, right? So we're just going to copy that. So empty is empty. 1 kv key value is just vector with 1 in it. Otherwise, we're going to have a recursive list. So this is the chain, and then we have another kv here. And then we're going to push that kv in list. We're done. Run the tests. First try, right? First try? First try? Yes. And we have 69 tests. Are you a software developer at work? I really shouldn't talk about work. But I can say I've been a software developer for like 20 something years. And I guess I can say I'm still a software developer, right? Yeah. But my job doesn't let me do open source contributions, games and apps, and I'm not allowed to talk about what I do there. So my stream is working on hobbies that have nothing to do with my work. I don't use Rust at work, for example. Okay, do I have time for maybe one more? One more, sir. Key values. Oh, right, we can plug it into expression, right? Because expression allows you to have a key value in here. Where was it? Oh, let's just look for it. key value. Right, it's literal map. That's what it was. So you can have a literal map where you just have keys and values in with braces around them, and that's interpreted as an expression. So that would be, because we use delimiters, we can put that in at the expression 0, right? We can just put it in there. Used to work for a patent company masqueraded as a software company. If you ignored or were unaware of that fact, it was a fun place to work. There are companies like that, right? That they say they're software companies, but they really just own a bunch of patents and they make all their money off licensing. Yeah, let's put it here maybe. Where was the other thing we had? I guess I should look at the grammar to see. Or innermost expression grammar. I guess that was it. So expression 0 it is. So I guess we'll put it above the parentheses one. Where was that? Literals, and then here we go, sub-expressions. So instead, we're going to have key values in braces. Well, that's literal map, right? So it's actually not a literal now that I think about it, because if key values is allowed to have an expression can have a reference in it, it's not a literal anymore. Yeah, if an expression could be a reference. So it's not really literal anymore. A literal would mean it's known at compile time, but for us, it's not known. We have to actually hold on to it as an expression. So let's not call it a literal map. Let's just call it a map. Right? It's a map of expressions to expressions. So we would have an example of that. So we have to put left brace and right brace in here. And then we would have our map. We'll just keep it simple, right? I'm just going to indent that just to make it easier to read. So it would be, sure, we can use integers, but we have to have a colon between them, right? And then like another integer, 67. I don't know why I like 42 and 67, but I do. So we should get back an expression of a map, and the map will contain a key value. Actually, it's a vector of key values. So one key value would be, why ignore that test? We have to actually import the key value type. Key value. Now I can code that up, right? What does it not like about this? Too many of these. There we go. So key value, fill structure fields. Didn't like my missing comma there. So the key is going to be, let's put this on another line because it's a little bit long. It's going to be expression, literal integer 42. And the value is 67. Okay. So there is no map expression, so we have to go to expression and declare it. Too many things. Okay, here we go. An expression can have a map, which is a vector of key value. Key value, import that. Cool. And then this is going to break because we haven't written the grammar rule for it. So let's watch it break first. Test-driven development, right? It should say it won't parse as a map. We get an error unrecognized token. It doesn't like the left brace. So let's teach it. We're going to teach expression parser what it means when you run into a left brace. Actually, all we need to do is say that it is a key values, and that reduces to expression map KVs, right? That should be all I need to say. Just add one line. And then going back, now it should pass, because that's how awesome we are. And 70 tests, please pass. Why is it taking so long to build? Uh-oh. Do I have syntax error? Did I break it? I did break it. Is that why it's taking forever to build? It's probably like, I don't know what he means by key vales. Maybe I should go onto the internet and look up key vales. I would have expected an error. I wouldn't have expected it to just go into a weird infinite loop. How about I just kill that? That's interesting. So we managed to break Lollerpop, right? Probably with that error. So EU, and then it works, right? Key values, what? No definition found for key values. Did I misspell it above? Oh, I misspelled it there too. Hold on, does that mean I misspelled it in other places? It was just 2 places here. Thank you for that. Does that mean that actually we have a problem with the parser generator? Is it stuck? I think we broke it. I think we broke it, chat. We broke the parser generator. It's dead, yeah. I think I know why. Because this is infinitely recursive, right? Think about it. If an expr 0 can be a key values, what's a key values? A key values is an expression which goes all the way back down to 0, where we can run into another left brace, right? Actually, it should be able to resolve that, right? Left tail recursion bug. I don't know, it does seem to be stuck. Doesn't it? What incarnation is going on? I think I broke Lollerpop. I broke the Lollerpop. Broke it. Well, shoot. I have no diagnostics. I don't know why why. Oh, there it goes. It just took it a long time. Okay, so there is a lot of... Oh, because it's ambiguous. Ah, yeah. So we have to factor it into our operator precedence. We can reduce to key values, but we can also reduce to a key values. We have a hungry cat guest in the office now. Key values in. So we basically complained about all combinations between key values and the other kinds of operations that we could have. Hey there, Owen Codes. How are you doing? Trying to understand what these error messages are. It took a long time because there are a lot of different production rules for key value, right? It has to go through all the levels of operator precedence. .44 and 45 seem to be the two that are contending. Local ambiguity detected. After having observed a comma, key values, comma, key value, at that point the next is R shift and the parser could proceed in two different ways. First, the parser could execute the production at 44, which could assume the top key value, produce a key values. This might then yield a parse. Why is a key value? Oh, right, a single key value, right? It might look like that. Alternatively, it could do 45. It would take the top three tokens, key values, comma, key value, right shift. Actually, I don't understand that. This one has a comma, but this one had a right shift. So why, when it, Can Bison detect ambiguities in the rules? Yeah, it can. And usually the way you fix those is through operator precedence. I don't remember doing that for this rule, but maybe I did. Key values. I thought I just relied on the braces. Am I missing braces maybe in mine? This is just a comma separated list of, and the key value is something colon something else. Maybe I just made a mistake in here. Comma, right? And then a key value is colon. Wait, I forgot the braces. That's what it is. I forgot the braces. Son of a... Where did I put the braces on that? I put it in the expression rule. Okay, so that's the bug. This has to have L brace and then R brace. Yeah, exactly. Get off my lawn is correct. Missing the braces in key values. That's actually around the key values. That's how you use the key values as an expression as you put it in braces. Do you know what bond.toml is? Nope. I don't know what bond.toml is. Okay, it doesn't know what lbrace is because we didn't map it here. lbrace token lbrace. So bond.toml, what is bond.toml, right? Regalius 3? And how are you doing? rbrace. Okay, let's see if that works. It looks like it's It looks like it's at least building. Nope, no, it worked. Okay, cool. Run the tests. Run those tests. Failed. Oh, because brace is now something that can show up at expression levels 0, 1, and 9. That's a bug. Expression 9 should have been test expression 9. Let me fix that before I forget. This should say test expression 9. Okay. Yeah, so we need to add like lbrace as a possible next token, right? Right before lparen. lbrace. Okay, and then also in expression 1 and 0 tests. Yeah, I should probably finish work or finish the work here and go to real work, paid work, because I'm starting to get pings from Slack. Usually means that people are trying to get my attention. Yeah, everywhere basically where it says, hey, this next thing is an expression, so we expect one of these things, right? Invalid token in expression 9 tests. Invalid token. Where are you, invalid? Here you are. Yeah, I need the left brace there. That's probably it. This will just work, right? It's like package.json for bun runtime. It's a binary file. I was wondering if you could use this to parse it. Let's see. Bun.toml. Wouldn't it be the toml format? Yeah, this is just text. Why would we need a binary file parser to parse this? To answer your question, though, literally, I could. The way it would do it is we would have to match first lines, right? And then of the lines, we would want to break it up into name, version, blank line, author line, and then like author. And author would have name and email in it. Oh, so there is a binary file which maybe it's this? I don't know. But so I may be answering it in a more broad way. The answer is yes. You could use my tool even to parse text, but it's sort of like, I can't think of the word. It's like unnecessary because you could already parse this much easier knowing it's text just by using like split on new line and all that stuff. Bun.lockb. What does that look like? The lock file? Ooh. So how do we look at it? So the first thing you need to find out for any kind of binary format is where is it specified? Where is the format specified? So this is not specifying it. So that means the specification for that is somewhere else. So we would have to find it. So if you can find the specification for this file format, then I would hope that the answer would be yes, but there are certain kinds of files might require like more exotic parsing intrinsics that I would need to add. We could make that a fun experiment later. Right now it's GIF, but who knows? We could do a lockb format maybe. Okay. Yeah, we passed all our tests. I think I need to wrap it up because I'm getting pinged at work. Even though my meeting's not till 11, maybe people are asking me questions before the meeting. Go straight to Bun's code. They still very beta as far as document, so they probably don't have a document. That's poor form, but understandable. Yeah, we'd want to find like a document, like for GIF, it was I have a copy of it actually. This one. So in GIF's format, they published this in 1989, right? They define their grammar in BNF, so it's actually pretty easy to map this to mine because mine kind of works with this. It's just that constructs like the 0 or more are a little bit difficult because we have to do a look ahead trick where we have a local variable called next, and we have to have this loop construct. The loop construct is what we're always going to have when we have this 0 or more. It's just this weird look ahead, and then the checking to see if it's going to be a trailer to break out. So this trickery is what we need. That's sort of implied by this. This is implied that the data ends when we see a trailer, which means we're looking ahead. Is it a trailer? No, it's a data. Is it a trailer? No, it's another data. Is it a trailer? Yes. Okay, no more data. The next thing is a trailer. Well, you're welcome. Get off my lawn and Regalias 3. I'll be back maybe later tonight because it's the weekend. If not, maybe the weekend, like Saturday, Sunday. Depends on how things go. What else is going on at home. If not tonight, and if not this weekend, then Monday. Yeah, I'm getting the pings from Slack are increasing. Slack is intensifying. Is Primogen still going? Ooh, someone's doing low-level embedded Rust. Is low-level learning is doing embedded Rust. Why don't we rate him? Full name is a mouthful. Nickname is BP. Okay. You're welcome for the stream. Hey, let's go watch low-level programming. While I go do something called job, you can go do something called watch low-level learning. Can I click that and then like mute it really quick? Yeah, I can. All right. I'll see you guys later. All right. Take care. Bye.